Good day, grade 10 learners. Welcome to our mathematics lesson. I am Skolile Ngube, and this lesson is proudly brought to you by the Gauteng Department of Education. I hope you are ready for the lesson, grade 10s. We are doing the quadratic functions and the hyperbolic functions. We want to see the effect of parameter A and parameter Q on these two functions, on the quadratic function and hyperbolic function. Let's be ready for our lesson, grade 10s. It is a bit cold today, but we have to do what we have to do. We have to continue with our lessons. Make sure you have your book with you there, your pen, your pencil. If I give you work to do, please do it. Let's be ready. Right, let's look at the objectives. At the end of the lesson, you should be able to understand the effects of A and Q on the graph defined by f of x is equal to x squared. What type of a function is that? What type of a graph is that? That is a parabola, or you can say quadratic function. And also f of x is equal to 1 over x. What type of a function is this one? It is hyperbolic. It's a hyperbola. Okay, so we're going to look at the effect of A and Q in these two types of graphs. Okay, in grade 10 we have done quadratic functions, we have done hyperbolic functions, we've done algebraic equations. We're going to apply our knowledge about algebraic equations and also function notation. So this is what we have learned in the previous lessons, and we're going to use these in this lesson. Right. Let's go to the activity. On the same set of axes, plot the graphs of f of x is equal to x squared. All right, g of x is equal to half x squared, and h of x is equal to 2x squared. All right, let's just have sketches of this graph. There's no need, I don't want you to plot all the points, but if you forgot, you can use the table method. But I want to see the effect of A, like f of x, A there is 1, g of x, A is half, and then h of x, A is 2. I want you to show the effect of A using these three graphs. So just sketches are fine. But if you forgot how to sketch these graphs, you can use the table method. Let's try to do that in 5 minutes. Welcome back, grade 10s. Let's mark our work and also discuss. Right, so let's start with, we have the graph of f of x. Right, this is the parent graph. This is the parent graph. A is equal to 1 here. For f of x, a is 1. So now, the graph of g of x, is it going to be wider than f of x or narrower than f of x? It is going to be wider. Remember, we said that if a increases, the graph becomes narrower. If a decreases, the graph becomes wider. So g of x is wider than f of x because a is half and is smaller than 1. Okay? Right. What about h of x? Compared to f of x, is it going to be narrower or wider? We're comparing here, a here is 1, a there is 2. So it means h of x is going to be narrower because a 2 is greater than 1. Okay, so h of x is going to be narrower. Do you remember that? The effect of a, the vertical stretch. Okay, that's what I wanted you to do there. Right, let's move on to the next part of our lesson. I want you to be engaged with the lesson and make sure that you do the discussions and do what I ask you to do. Okay, right. Now, the following are the graphs of f of x. The red graph, I tried to use color coding there so that you can see the f of x there is the red graph if you check here, and then g of x, the blue graph, and h of x, the green graph. So the following are graphs of f of x, g of x, and h of x. Discuss the following key features for each graph. You are writing these in your book, in your workbook. I want you to write about the domain and range for each graph, x and y intercepts of each graph, the axis of symmetry for each graph, concavity, is it concave up or concave down, and then is it minimum or maximum. You are free to discuss with your colleague there, okay, but don't make noise. You're just discussing and writing your work. Let's do this in 5 minutes, and then after 5 minutes we're going to discuss. I'm going to lead the discussion. Let's do that. 5 minutes. Welcome back, great 10th. Now it's time for us to discuss. I'm going to lead the discussion. So what you're doing now, you are correcting your work and also adding notes. You're writing your notes and correcting what you have done. Okay, if it's correct, if you've done, you got the correct answers, well done. Okay, let's do the discussions. Right, let's start with the domain. The domain for f of x. Remember what the domain is. Domain is what? Is the x values, the input values. So which input values can we put into this function? So the domain is from negative infinity to infinity. So x is an element of real numbers. Imagine any number we can put into this function. Negative 1 million, positive 1 million, negative 100,000, positive 100,000, negative 1, positive 1, 0. We can put all these numbers. So x is an element of real numbers from negative infinity to infinity. So x, element of real numbers, or you can write it like this. X is from negative infinity to infinity. Okay, so for infinity, we use the round bracket. We cannot include infinity, so that's why we use the round brackets. Remember, square brackets for what? For included. Round brackets, not included. Okay, right, g of x, the blue graph, still on the domain. Is it going to be different? It is not different. It is still what? X element of real numbers, or we can say x element of negative infinity to infinity. Okay, let's check the green graph. What's the domain for the green graph? Is it going to be different? We can put the values from x values from negative infinity to infinity. So the domain for the green graph for h of x, it is also x element of real numbers, or you can say x is from negative infinity to infinity. So we can say that for a parabola, for a quadratic function, the domain is x an element of real numbers. All of them, unless we go to the restrictions. But now we're not doing any restriction. So the domain for a parabola, x an element of real numbers, or from negative infinity to infinity. Don't forget that. Okay? Right. You write your notes as we discuss. Otherwise, we won't finish if I wait for you to write notes and all. As we discuss, make sure you make your corrections and write your notes. Right. Range. What is range? What is range? When a graph is concave up like this, it is the minimum value. What is the minimum value? It means we cannot have a value which is less than that. If I say, I want a minimum of 5 learners to come to the front, what do I mean by that? It means I'm saying I want 5 or more learners. That's the minimum. Minimum 5, I'm saying 5 or more. So now, if you look at x, the minimum value here is 0. Y can never be less than 0 for this red graph, for f of x. It's 0 or more. You see that? So y, the range is the output values, the y values. So y is greater than or equal to 0. Do you see that 0 is included? 0 or more. So you can write it like this and say y is an element of 0 included square bracket to infinity. Okay, so you can say y is greater than 0, or y is an element of 0 included to infinity. I want you to take note of this. The value of q. For f of x, we can say this is plus 0. You can say our q is 0. Because I want you to observe a certain trend here. Okay, let's go to g of x. Right. g of x, the minimum value is 2. It means the y values cannot be less than 2. The y values are 2 or more. This graph, you can substitute the x values, goes down, gets to 2, and then when it gets to 2, it goes back up. So y can never be less than 2. So y is 2 or more. So y is greater than or equal to 2 for g of x. Or we can say y is an element of 2 to infinity. Remember our WhatsApp line, grade 10, 063 508 1301. Please let us know if you need more explanations or want us to clarify something. Send us your chat, 063 508 1301. Right. I want you to check the trend here. What is our value of q? It's 2. Do you see that? Let's go to h of x, the green graph. Right. The minimum value here is -1. The minimum value is -1. So it means y is -1 or more. So y is greater than or equal to -1. Or you can write and say y element of -1 included to infinity. Okay? Right, check this. Our q value is -1. So from this, we can conclude and say that if the graph is concave up, if the quadratic function is concave up, then the range is y greater than or equal to q. Oh, let me change the color here. This one is not clear. Y is greater than or equal to q. We can generalize and say that for graph that is concave up, when a, this is when a is greater than 0. This means, we use this a lot. A greater than 0 means a is positive. A less than 0 means a is negative. A number which is less than 0 is negative. A number which is greater than 0 is positive. Right. So we can say for our parabola which is concave up, our range is y greater than or equal to q. Or you can say y element of q to infinity. Don't forget that, grade 10s. Okay? Right, let's go to the x-intercepts. The x-intercepts, f of x is at the origin there. That's why it cuts the x-axis, or it touches the x-axis at the origin. So the x-intercept there is 0, 0. Okay? And then we go to g of x. There's no x-intercept, so we write none there, g of x. It is possible to have a graph that does not have x-intercept. And then you try to solve the equation, find that you are not getting a solution. Let me just show you. Let's say we have g of x, this is g of x. We try to solve for x-intercept here. Remember, to find the x-intercepts, where there's y, we put 0. So where there's g of x, we put 0. So 0 is equal to x squared plus 2. Let me just do a simpler one where I square root both sides. So I bring 2 this side, become -2 is equal to x squared. And then what do you need to do? To square root both sides. If you square root here, square root there, you can see that we cannot have a square root of a negative number. There's no solution. You try to solve a quadratic equation, there's no solution. It means the x-intercepts are not there. But if the x-intercepts are there, you will get a solution. Okay? And then h of x, are there any x-intercepts? Yes, seems like it's cutting the x-axis there and there. And we can solve for these algebraically. Right, this is h of x, I'll put a 0 here. So it becomes 0 is equal to x squared minus 1. X squared minus 1, that is difference of 2 squares. So 0 is equal to x minus 1, x plus 1. Therefore, x minus 1 is equal to 0, or x plus 1 is equal to 0, meaning that x is equal to 1 or x is equal to negative 1. We can see that here. You see that? So we have the x-intercepts at negative 1, 0, or 1, 0. Okay? That's how we find the x-intercept. Okay? Let's go to the y-intercept. We're going to take time on this one, then the next ones, it will become easier for us. Okay? The y-intercept. For the red graph, 0, 0 at the origin. Okay? And then g of x. What is the y-intercept? Which is actually the turning point also. Is 0, 2. Okay? I want you to see something. Here, q is 0, q is 2 there, and then h of x, 0, 1 here. 0, negative 1, sorry. 0, negative 1. Do you see that also q there is negative 1? So for a graph, for a parabola, the coordinates of the y-intercept are what? For this particular type of parabola we're looking at in grade 10, it's going to change when you go to grade 11. Remember, grade 11 we're going to do some shifts, horizontal shifts, but now grade 10 is easy. We're just doing vertical shift up or down. So the y-intercept will be 0, q. Oh, this ink is not 0, q. Okay, that is the y-intercept, 0, q. So you can get the y coordinates of the y-intercept from the equation of the graph. And then the axis of symmetry. Don't worry about this. Axis of symmetry means the line of symmetry. We've done the lines of symmetry from primary school, isn't it? Right. A parabola is symmetrical. We can draw a line of symmetry here. You see that? This line, this dotted line, is dividing a parabola into 2 equal parts. A parabola is symmetrical. You have to know that, you have to remember that. Okay? So what's the equation of this line? It's actually the y-axis. Can you say the answer? What is the equation of the y-axis? What is the equation of the y-axis? Or a vertical line that passes through the origin, passes through 0. X is equal to 0. Remember, equation of a vertical line, x is equal to a number. The number is where it casts the x-axis. And then the equation of horizontal. Equation of a vertical line is x is equal to a number, where the number is where the graph casts the x-axis. And then the equation of the horizontal line is y is equal to a number. Okay? Right, so the axis of symmetry here is x is equal to 0. I'll end up using the same ink here. This is taking time. Right, x is equal to 0. In the next ones, I'll use the same ink. Otherwise, it's changing things, giving us problems. Let me use red. Okay, red. Okay, I'm not going to change ink now. Right, so x equal to 0, x equal to 0. That's the axis of symmetry. Then concavity. Are the graphs concave up or concave down? If a is greater than 0, the graphs are concave up. So it's concave up, concave up, then concave up. Okay, right, concave up. So if a is greater than 0, the parabola is concave up. And then do we have the minimum point? Yes. I want you to observe the trend here also. The minimum point here, the minimum point or the minimum value is y is equal to 0. You see the q value there is 0. Then the minimum point for g of x is y is equal to 2. Do you see the q there is 2? And then the minimum point for h of x is y is equal to negative 1. Do you see that Q also there is -1? So the minimum value for a graph, for a parabola, is going to be, in this concave up, we talk about the minimum value, but concave down, we're going to talk about the maximum value. So it's y is equal to Q. Okay, that's the y value there for the minimum point of a graph or a parabola which is concave up. But let me give you 1 minute, just 1 minute to just catch up and make a few notes, then we move on. 1 minute. Welcome back, grade 10s. Remember our WhatsApp line 063 508 1301. Okay, right. Now let's move on to the next graph. But now we're still on the parabola. But now when a is less than 0, if a is less than 0, oh, before we do that, I forgot. Before we do that, let's discuss the transformation. You know transformations. We talked about translation, we talked about reflections, we talked about enlargements, grade 9. Okay, so what type of transformation happened here for f of x to form g of x and h of x? It's actually translations. If you check, the red graph is shifted upwards by 2 units to form g of x. And then the red graph is shifted downwards by 1 unit to form h of x. So that's the effect of Q. So plus 2, if Q is plus 2, it means the parent graph is shifted upwards by 2 units. And then if Q is -1, it means the parent graph is shifted or translated by 1 unit downward. So it's just the vertical shift. So what changes here are the y values. The x does not change if it's vertical shift. It does not change. You see, when I move from this point, this is 0, 4. And then I move to this point, this is 0, 6. Do you see that the x's are not changing? What changes is the y. So vertical shift changes the y values. So it is the range that is going to be affected. It is the y-intercept that is going to be affected. It is the minimum or the maximum values that are going to be affected. The domains are not affected by the vertical shift. Okay, right. Now, let's look at this one. The following are the graphs of f of x. Now, a is negative. There's -1 there, and negative, all of them, -1 there. Okay, discuss the following key features for each graph. But now I'm going to give you 3 minutes because we've done this similar to what we did in the previous one. So I'm going to give you 3 minutes. Let's try. Welcome back, grade 10th. Let's discuss. Right, so the other things are just the same. We're going to concentrate on the range, the y-intercept, and the maximum point. Okay, right, the other things are fine. So I'll give you 1 minute maybe to just make your few notes after this discussion. Right, so let's look at the range for the parent graph, which is f of x. Now, this point, the turning point there, is the maximum value. Again, if I would say, last time I said I want the minimum, a minimum of 5 learners to come to the front, meaning that I want 5 or more. But now if I say I want a maximum of 5 learners to come to the front, a maximum of 5 learners, it means 5 must be the highest. It can be 5 or less. You see that? So maximum, it means maximum of 5, means 5 or less. So it means we cannot have the y value for f of x. We cannot have a y value that is greater than 0. It can be 0 or less. Remember, for the y's, this is our negative infinity, and then this is our positive infinity. Okay, right. So now the range is going to be y less than or equal to 0. Remember, our 0 for f of x, for q for f of x is 0 there. Or you can write and say y is an element of from negative infinity to 0. Negative infinity to 0. 0 included. So we use the square bracket. Okay? Right, g of x, the maximum value is 2. It means the y values can be 2 or less. So y is less than or equal to 2, or you can say y is an element of negative infinity to 2, 2 included. Check the 2 here. The value of q there is 2. Okay, and then h of x, the maximum value there is negative 1, meaning that the values of y can be negative 1 or less. Right, so it means y is less than or equal to negative 1, or you can say y is an element of negative infinity to negative 1 included, negative 1 included. There's a link between the range and the value of q. Do you see that? So if the graph is concave down, if a is less than 0, if a is negative, then we can say the range is y less than or equal to q. Okay? Or you can say y is an element of negative infinity to q, q included. You can generalize it. Remember that. Okay? The y-intercept. The y-intercept. We have to do the hyperbola, and time is just not on our side. So the y-intercept, f of x, 0, 0, the red graph, that's where the graph cuts the y-axis there. G of x, that's the y-intercept, 0, 2. And then h of x, 0, negative 1. Okay, that is the y-intercept. And check the link between the y-coordinates of the y-intercept and q. 0, 2, negative 1. 0, 2, negative 1 there. So you can say the y-intercept is 0, q. Okay, 0, q. Right? The maximum point. The maximum point. For the red graph, we've talked about this. Maximum point will be 0. So y is equal to 0 is the maximum point. For the blue graph, g of x, y is equal to 2 is the maximum point. You cannot have y values above 2 for the blue graph. For the green graph, y is equal to negative 1 is the maximum point, which is this one here. Okay? So here we can generalize and say the maximum point for a graph which is concave down is y is equal to q. Okay? Right. Let me give you 1 minute to just make a few notes. Right, welcome back, great turns. I really hope you managed to understand this part. Please, if you did not understand, send us a chat 063 508 1301. Okay, let's do that, great turns. Now, describe the transformation. It's still the same thing. Now, we're looking at the red graph as our parent graph. Some people say the mother graph. And then, what happens to it to form g of x? It is shifted upwards by 2 units. Plus 2, positive 2 means goes up by 2 units. And then to form h of x, is shifted downwards by 1 unit. So negative q, it means it's the translation movement downwards by 2 units, isn't it? Okay, right. Now, that is that on the effect of a and q on the parabola, on the quadratic function. I want us to look at the hyperbola. We may not cover everything, but let's just start. We're going to learn something. We're going to benefit. Yeah, let's have our 3 minutes. Let's make it 4 because we're going to sketch the graph. Given f of x is equal to 2 over x, sketch the graph of f. Just a sketch, it's fine. I want to see the shape and the asymptotes. That's what I'm interested in. And then state the domain. Try that. And then state the range. Let's try to do that in 4 minutes. Welcome back, greetings. What type of a function is this? What type of a function is this? This is a hyperbola. This is a hyperbola. A hyperbola is how many asymptotes? It is how many asymptotes? It is two asymptotes. The vertical asymptote and the horizontal asymptote. Like this one, the asymptote, we're going to have the horizontal one, which is y is equal to 0. And then we're going to have the vertical one on the y-axis, which is x is equal to 0. Those are the two asymptotes. And then if you're sketching the graph, you could have even used your table of values. Okay? You find that the graph is shaped like this. It has two arms. One in the first quadrant and then the other one in the second quadrant. Remember, this depends on the value of A. If A is positive, let me just say, if A is positive, if A is greater than 0, the graph or the arms of the hyperbola will occupy the first quadrant and the third quadrant, if A is positive. But if A is negative, if A is less than 0, the arms of the hyperbola will occupy the second quadrant and the fourth quadrant. This is one graph with two arms, but it's one graph. It's just a what? We call it a discrete graph. It sort of appears this side, then it jumps and appears on the other side. Okay, while graphs like parabola are continuous like that. You see that? So this is the effect of A on the shape of the hyperbola. Okay, right. Now mark your work. Did you manage to sketch a graph like that? Mark your work. Do you have the asymptote, the vertical asymptote, the horizontal asymptote, and the shape of the graph? Is it correct? With the two arms? Okay. Right, state the domain of F. State the domain of F. Now, the domain, remember, we're talking about the x values. So it means from negative infinity to infinity. But there's a condition here. The graph cannot appear or does not touch the asymptote. X is equal to 0. You see that? It's all the values, all real numbers, but x cannot be equal to 0. Okay, so the asymptote is excluded. So we can say there are different ways to write this. So we can say x element of real numbers, but there's a condition, x not equal to 0. You can write it like that. You don't need to write all the different formats. Just pick one format. And then you can say x is less than 0 or greater than 0. If I'm saying x is less than 0 or greater than 0, then I'm not including the 0. So you can write like that, say x is less than 0 or x greater than 0. That's another way. Or you can say x element of negative infinity to 0, 0 not included, round bracket. Or 0 not included to infinity. That's another way of writing the domain. Okay, then the range. The range now is the y values. We are saying here y cannot be equal to 0. So y can be greater than 0 or less than 0, but cannot be equal to 0. So that's the range there. So y, you can say y is element of real numbers, but y cannot be equal to 0, or y is not equal to 0. Or you can say y is less than 0 or y greater than 0. Or even say y is element of negative infinity to 0 not included, or 0 not included to infinity. Did I write x here? No, a big mistake. The range is the y values, domain x values. Remember that from input and output values that we did in the lower grades, even when you started the function concept. Okay? Right. Let's do one or two more questions. Then I think what was concluding our lesson, just two more questions. Some of the answers are here. Okay, some of the answers are there. So if you're listening and seeing what we're doing, you have the answers for one of the questions that I have in the next slide. All right. Write the equations of the asymptotes. Don't move the video backwards. You have to remember there. Right. Write the equations of the axis of symmetry. Let's do this in 2 minutes. Then after 2 minutes, we'll discuss and we'll have to conclude our lesson after that. Let's do it 2 minutes. Right, welcome back, Cretans. Right, what are the equations of the asymptote? Say there are two equations, the vertical asymptote and the horizontal asymptote. This vertical asymptote passes through the x-axis where x is equal to 0. That means it is x is equal to 0, the vertical asymptote. The horizontal asymptote also passes through the origin where y is equal to 0. So this is y is equal to 0. So the equation of the horizontal asymptote is y is equal to 0. The equation of the vertical asymptote is x is equal to 0. Those are the two equations. Okay, right. Then write the equations of the axis of symmetry. A hyperbola is also symmetrical. It has two lines of symmetry. There's one that passes through or cuts the arms. We know about the increasing graphs and decreasing graph. So this one is increasing. As you move from left to right, the graph is going up, so it's increasing. The increasing one is a gradient of +1. Remember the equation of a straight line? Y is equal to mx plus c. So it means it's going to be y is equal to x plus c. And then c is the y coordinate of the y-intercept. So here the y-intercept, the y-coordinate of the y-intercept is the origin, which is 0. So the equation of this graph will be c is 0. So the equation is going to be y is equal to x. These axes of symmetry, they pass through the points where the asymptotes meet. So the asymptotes meet here at the origin. If they are shifted up, then these lines of symmetry will pass through that point where the asymptotes meet. It's not the origin every time because there's vertical shift. So if these points shift, let's say the asymptotes are now here, they are meeting here, then this line will pass through this point where the asymptotes meet. Okay? And then the second one, the second axis of symmetry passes through the same point, but now this one is in between the arms. This one is decreasing. As you move from left to right, the graph is going down. That is decreasing. Decreasing means negative gradient. Increasing means positive gradient. Remember, m is the gradient. So it becomes y is equal to negative x plus c. And in this case, our c is at the origin. So c is 0. So our equation is y is equal to negative x. So these are the two equations of the axis of symmetry. Okay, right. Now let's just take a short break, and then after break we are going to summarize our lesson. Let's take a short break.
The road to success, to becoming a successful student, is through commitment. Commitment to studying, commitment to putting in the extra hours in your books. I know it's not going to be easy. Actually, no one said it will be easy. But if you keep pushing and if you keep believing a little more in yourself, then the results will show in your life. Commit and become.
Welcome back, greatest. Let's summarize. We're going to just summarize about the quadratic function, about the parabola, because the hyperbola we didn't do a lot. So let's just summarize about the parabola. The quadratic functions of the form f of x is equal to x squared plus q. For this type of functions, the domain, we said x an element of real numbers, or you can say x is an element of negative infinity to infinity. Okay, remember that? And then say the coordinates of the turning point will be 0, q. It means the turning point is at a point where x is 0 and where y is q. The equations of the line of symmetry is the axis of symmetry for the parabola. The one we just did before this summary was what? For the hyperbola. Don't forget. We're talking about the parabola, the concave up, concave down one. X is equal to 0. And then if a is greater than 0, if a is positive, that means when the graph is concave up, the minimum value is q. Just from the q value there. And then the range will be y greater than or equal to q, or you can even write it in this form. We discussed this a lot. We took a lot of our time doing this. And then if a is less than 0, meaning that if the graph is concave down, it means the maximum value. You see, we're talking about the maximum value that is equal to q. And then the range will be y less than or equal to q, or you can say from negative infinity to q, q included. Thank you very much, grade 10s. Let's meet every Thursday at 9 a.m. Every Thursday, 9 a.m. We're going to be continuing with our functions. Let's meet next week, grade 10s. Goodbye.